To my channel. I am Professor Kodandramaya. Here in this channel, I give all kinds of updates on technology and abroad education. Here in this video, I would like to present on practical tricks every Python developer should have. Python has become a popular programming language because it is clear, versatile, easy to learn, and it has plenty of useful libraries for different tasks, from web development to data science and cybersecurity. Python programmers are highly in demand. But like all programming languages, in Python, everything depends on you, that is the programmer. You decide whether your code looks professionally or ugly. Fortunately, Python has a vast array of built-in features that can help you write code that is elegant, concise, and expandable. The kind of characteristics you expect from a professional programmer. Here some of my favorite tricks which I think every Python developer should know. Point number 1. List comprehensions. List comprehensions are one of the key features of Python that help you write code that is more concise and elegant. Let us say you want to create an array containing numbers from 1 to 100. The convenient way to do it would be to use the range function. But what if you wanted to do something more complicated, such as creating a list of squares from 1 to 100? In that case, the classic way would be to use for loop. This is the standard way that most programming languages support. But fortunately, in Python, list comprehensions make things a lot easier. Here is what the same code would look like when written in list comprehension mode. You can use list comprehensions to pack several instructions and expressions in the brackets that define a list. They are much shorter and more elegant than for the loop. And there is a lot more you can do while still keeping your code clean. For instance, say you have a function is prime that checks an input number and returns true if it is a prime number. Point number 2, zipping. Another Python feature that comes handy every once in a while is the zip function. Zip combines two or more lists into a single variable. Say you have collected list of customer names, their ages and their favorite ice cream flavor. Using zip, you can consolidate all three lists into a single list where each entry contains a tuple with the name, age and preferred flavor of the customer. This is what your customer is. Ice cream list looks like after zipping the data. The third point is counting items. Often you want to know how many times a certain value occurs in a list. For instance, say we have collected a list of 1 to 10 ratings from an online survey. To simulate this, we will generate a list of 1000 random numbers from 1 to 10 using the random int function. Now we want to know how many of each rating is included in the list. One way to do is to use the built-in count function of the list dot count. Takes a value and returns the number of times that value occurs in the list. However, this only works if you know in advance what is the range of values in your list. In case you don't know the possible values, you can use a set which creates a list of unique items contained in another list. For instance, you have a list of names and want to know how many times each name occurred. You can use the following code. Alternatively, you can use the counter class which specializes in counting values in lists. Counter provides some added functionality such as the most common function which gives you the most occurring values in a list. For instance, the following code will print out the three most popular values. Try for that. Fourth point is enumerating. Sometimes you want to keep track of the count of items as you iterate through a list. Say you have a list of customer names and you want to list them along with their index number. It's not very elegant. Notice mismatch, the index and the counter. Fortunately, Python has an enumerator function that makes your index tracking code much more understandable and pleasing to the eye. Enumerate function takes two arguments, the list you want to enumerate and the starting number of the counter, and gives two outputs each round of the loop, the counter value and the list item. Here is what the same problem is solved with the enumerate. Fifth point is parameter expansion. Say you have a function that proposes student information. In many cases, the values you want to pass the function are included in a list or a dictionary object that has been populated from a database or next file. In such cases, calling the function would be a bit clunky. Fortunately, Python parameter expansion feature which enables you to directly pass an entire list to a function. By adding an asterisk at the beginning of the list name, you expand it to its individual values before submitting it to the function. Parameter expansion with lists works as long as the number of parameters and their sequence is similar to the parameters of the target function. In case of a mismatch, it will raise an error. You can also use parameter expansion with dictionaries, in which case the order of values does not matter. You only need to have keys that correspond to your function parameters. Parameter expansion for a dictionaries requires the double asterisk operator before the object. One of the benefits of using dictionary expansion is that if your function has default parameters, omitting them in your dictionary won't raise an error. The sixth point is type annotations. Python is a dynamically typed language, which means if you try to mix variables that have different data types, it usually finds a way to resolve the difference or raise an exception if it can't. But this flexibility can also result in unpredictable behavior. The function creates a list that is three concatenated copies of the list. This is clearly not that you wanted to do. Python versions 3.6 and higher provide type annotations, a feature that enables you to define the type of data each function argument should take. Here is how the type annotated mule function looks like. This format explicitly states that mule function takes two integer values. To be clear, type annotation won't prevent you from using the function in unintended ways, but there are some good reasons to use it anyway. First, defining the type of data is a form of documentation and makes it easier for other developers going through your code to understand what type of data you expect in your function. Compare the annotated and non-annotated versions of the function. But even more importantly, some code editors process type annotations and help you with features such as autocomplete and type errors. If you like this video, you can share and you can subscribe my channel. Wish you all the best. Wish you all the success in your career. God bless you.